Hi, my name is Gavin Ruane. I'm a student in CPE 133, Section 7, and this is my Lab 5 demonstration and submission video. So in this video, I'm going to be showing you my Lab 5 project, which is done on the Basis 3 board. This project is essentially, we're kind of adding to what we have been working on for the past few weeks in labs 2, 3, and 4. This time we're just kind of upgrading our little calculator, and it's going to be so much more useful and more relevant. So some highlights of this are, well, first of all the switches are going to be the same. We're going to have our switch right here that says whether it subtracts or adds. These switches over here are going to represent the number in binary, in signed binary, to use complement signed binary. But what's new is, well, we've used the 7-segment display before, but now this time it's actually going to be so much more useful. So I'll demonstrate this, but it's going to actually show a negative sign, and it's going to show all dashes if it's invalid. It's going to make so much more sense. It's like making it more user-friendly. We're also going to be using the buttons. So this top button, I'll show this more later too, of course, but the top button will clear and the center will enter, just like you would find on your normal like TI-84 calculator. A little different, but there's some similarities. So those are the main features, but the biggest things that we've actually implemented memory and registers. So when you do an addition, so I'll do a quick example right now. The number will show up just as we did. I know it's backwards, but the number will show up just as we've done in the past few weeks, but it's going to stay there until I hit enter for the next calculation. So I'm going to, change some of these switches. As you can see, it stays, but I'm going to hit enter, and okay, that one was invalid, but as you can see, it stayed there until I hit enter. So it's actually storing data this time, which is pretty cool. We can also clear it with this button if we want to go back to normal. All right, well, that's kind of the basics of this. I'll show any relevant data that may be useful for explaining this lab right here. But otherwise, that's it, and I'll get into my test cases. Thanks. All right, so let's get into our test cases for Lab 5. Okay, so before we actually do test cases, let me just go over a few quick things. So as I mentioned earlier, this time our switches are pretty much the same as the past few labs. So this leftmost switch is going to be whether we're adding or subtracting. If it's in the 0 position, we're adding. If it's in the 1 position, we are subtracting. These switches over here, let me reset them to 0 while we're at it. But so these 4 switches right here belong to A. And this is the 3rd, 2nd, 1st, and 0th most significant. And then these 4 over here, same thing, 3rd, 2nd, 1st, 0th, but they belong to B. And then here's a button map. So this time we're using these buttons. So the top button is going to clear our 7-segment display, and the center button is going to enter it when we're calculating something. And then on the 7-segment display, you'll notice that this looks similar to last week, but when we come upon a negative number, you'll see a negative sign over here. And if it's invalid, all displays will have a dash on them to show that it's invalid. Okay, let's get into the test cases. So these are pretty much the same as last week, but we're going to do them all again. And I have a few extra things that I want to demonstrate as well at the end. Okay, let's do 0 plus 0. Well, we're already at that right now. Let's enter. 0 plus 0 is 0. That is correct. Now let's do 0 plus 5. So that is this. And again, I'm going to be hitting enter this time. It doesn't do it automatically. 0 plus 5 is 5. That is correct. Okay, now let's do -7 minus 0. Okay, so we're going to do 1001 minus 0. Okay, and that is -7. As you can see, that negative sign just displayed over there. Let me turn the brightness down. Maybe that will help you view it. Oh, it's not going to work. Okay, well, that's okay. All right, let's do 2 plus 4. Okay, so that's going to be 0, 0, 1, 0, 0, 1, 0, 0. Let's enter. Oh, I think I have done something incorrect. Oh, I forgot to reset this. I'm sorry about that. So this is actually a good time to reset to demonstrate the clear button. So I'm going to hit the clear button. It's going to set it to 0 because I messed up. I did the wrong calculation. Okay, let's do 2 plus 4. 0, 0, 1, 0. 0, 1, 0, 0. Enter. 6. That is correct. Okay, now -2 plus -2. 1, 1, 1, 0, 1, 1, 1, 0. Okay. -4. Perfect. Now, 7 plus -4. 0, 1, 1, 1, 1, 1, 0, 0. Enter. 3. Positive 3. Correct. Okay, -6 plus 1. Okay, so -6 is 1, 0, 1, 0. That is that. Enter. -5. Correct. Okay, 5 plus 6. 0, 1, 0, 1, 0, 1, 1, 0. Enter. Oh no, it's invalid. So what is invalid is going to do these 4 dashes like this. And you might be wondering, why is this invalid? Well, because it's just how many bits we implemented into this project. It's just not going to fit in those specified 4 bits. So, and this is the same as last week's lab as well, but we're just representing it differently this time. Okay, now let's do -8 plus -1. So that is 1, 0, 0, 0, 1, 1, 1, 1. Okay, let's enter. And again, that one's invalid too. You can see that in last week's lab if you would like to see that. But that's, again, it's just going to be too big for our purposes here. Okay, so I'm going to clear that this time. And now I'm going to do 6 minus 5. So that is these two. That doesn't look right. Let me just double check something. Okay, let's clear. Okay. 6. Oh, I didn't set the subtraction thing. Sorry about that. Now that works. 6 minus 5 is 1. I'm just so used to the less user-friendly version. Okay, -3. So 1, 1, 0, 1 minus 1, 0, 1, 1. So -3 minus 5 is going to be positive 2, because this is like pretty much -3 plus 5. Okay. Now let's do 2 minus -5. So, okay, and then 1, 0, 1, 1, enter. Positive 7. Again, this is like 2 plus 5 pretty much. But we're just demonstrating that these all, our functions all work. Okay, -5 minus 3. So 1, 0, 1, 1 minus 0, 0, 1, 1. -8. That is correct. Okay, now 1 minus -8. So that, and we're in the minus position. That is invalid again because it's just too big for our purposes in this project. So we do want it to be invalid. Okay. And then the last major one, -4 minus 6. So 1, like that. And we're in the subtraction, enter. And again, that's invalid, too big, because we just can't handle that much data in this project. We can always add more if we needed to, but not right now, because that's not what we're doing right now. Okay, so those are the main test cases, but I also just wanted to reiterate these 3 other things. I kind of already demonstrated these, but just to show you. So to demonstrate the memory. So entering or storing, so literally we're just going to choose like the most random addition ever. Okay, well that one's invalid, but maybe, let's see, let's do this. Nope, no, I'm not going to do that. Let's make an easier one. Here we go. Okay, so that's 1 plus 1. And again, as you can see, I entered to store it. So that is storing it, and the best part about this, what's different about this from the other lab, is that before we would want to do a new calculation and it would change it immediately when I start moving these switches. It doesn't do that this time. So that's demonstrating the memory. It's showing that this basis board has the capability to store my previous value, even though I'm changing switches. It's saying, nope, I'm not going to do anything until I'm ready. Okay, now clear. Just click that button, it sets it to 0. That's as simple as that. Clear priority, can't really demonstrate this on the basis board, but you can see this in my timing diagram. There is one test case where both enter and clear are being clicked at the same time, and you'll see that the clear takes priority over this. So I just wanted to say that out loud here, but you'll see that in the timing diagram because you can't really click to both at once. You can, but you can't, if that makes sense. Anyways, that is it for my test cases. As you can see, I passed all of them. So let's write our 100% as I always do. And that's it for today. Okay, stay tuned for the next video.